In the opening exercise of this lesson, you are supposed to solve for x and y. So looking at the picture here, we should see that we have a right angle. And let me just do that in red so you can see it better. So here is my right angle right there. And so if this is a right angle on this side, then the other side of the line is also a right angle. And so I have complementary angles. So that means that this angle right here, from E to O to B, is a right angle, and it's 90 degrees. Which means that these two angles, this EOD and this DOB, are complementary. So I can write an equation, and my equation can be x plus 8 plus 2x minus 8, right? That's these two pieces here, this x plus 8 and this 2x minus 8. When I add them together, I should get the 90 degrees because they're complementary. So adding them together, I've got x plus 2x, which is 3x. 8 minus 8 is 0, so that 3x is equal to 90. And then if I divide both sides by 3, I have x is equal to 30. And that's the fastest way to get your answer there. There are other ways, but that's the fastest. From there, we need to figure out y. So we need to find some more relationships here. So if I look at this line next to y, and this other line that borders y, I see I have vertical angles here. And this next question says, name a pair of vertical angles. So A to O to C is a vertical angle. So AOC is a vertical angle, angle A. O is my vertex, and C, and angle D to O to B, D to O to B is also a vertical angle. So those two angles have to be congruent or the same measure. So I know that y has to be equal to this 2x minus 8. And we already solved for x right up here. So this 30 can be substituted into that x. So this is 2 times 30 minus 8, which gives you 60 minus 8, or y is 52 degrees. And so this is also 52 degrees up here. Now the last question down here says find the measure of BOF. So B to O to F is this piece over here. And you've got a linear, or three angles that add up to a line. So that's consecutive adjacent angles on a line. This one's 52. We don't know what this one is. That's what our goal is. And this one is 4x minus 24. So we know that x is 30, so I can say that this is 4 times 30 minus 24, which is 120 minus 24. And if I subtract correctly, I think I get 96 degrees. So if this is 52 and that's 96, I need to find my missing piece. I know that those three angles have to add to 180, and so that is going to be 52 added to 96. So that's going to be an 8, and that is going to be 8 of 14. And then I'm going to take the 180 and subtract the 148, and that will be my missing angle. And so I get 32 degrees. So this angle here is 32 degrees. And it says find the measure and justify all my calculations. So all the calculations that I did, I started by using complementary to get x. So I used complementary angles. Complementary. And then I used vertical angles to find y. And the last thing I did was I used the consecutive adjacent angles on a line. So consecutive, okay, I should just type this because this is consecutive adjacent angles on a line. There we go. Okay. So So then into our discussion, so if we want to make AB parallel to CD, so I'm going to make this line up here parallel to that line. So let's highlight those. So I want CD to be parallel to AB. I want to look at corresponding angles. So how can I use corresponding angles to prove that AB... So corresponding angles, that's whenever you pick them up and you drop them, you slide them over and drop them down. So that means that this angle A right here would correspond to this angle E. If you slid A down, it would land right on E. So angle A would be congruent or the same measure as angle E. How else could I prove this? Well, angle B would have to correspond with angle F. If you slid B down, it would land on top of F. So angle B would be congruent to angle F. And we have angle D here. Angle D should land on top of H. So angle D corresponds with angle H. And our last one, angle C would correspond with angle G. Angle C is congruent to angle G. Okay, same type of question. Now I want to use alternate interior angles to prove that the AB line is parallel to CD line. So my AB line is this one, my CD line is that one, and I want to prove somehow that those two lines are parallel. So in order to do that, I need to use alternate interior angles. So my alternate means opposite and interior means inside. So inside is in here. So that is inside my parallel lines. Alternate means opposite sides. So angle C and angle F would be congruent. They're alternate sides and inside. So angle C is congruent to angle F. And likewise, angle E would have to be congruent to angle D. So angle E is congruent to angle D. And those are alternate interior angles. Doing the same thing, we want those two lines. So AB has to be parallel to CD, and I want to prove that using the same side interiors. So same side of the transversal, interior inside the parallels. So inside, and I want on the same side, so that's these two. And they are supplementary, so that means that the measure of angle C plus the measure of angle E has to be equal to 180 degrees. And our other set would be this one over here. D and F are also on the inside, and they're on the same side. So the measure of angle D plus the measure of angle F has to be equal to 180 degrees. So quickly through the examples. 48, A has to be 48, and that is because those are consecutive. Okay, A and B, so this is when you take the 180, subtract 48, and you get, I think, 132. And that is because those are interior, same side, supplementary. Is there a reason on that one? Interior, same side, supplementary. B and 48 are on the same side. They are in the interior. They are supplementary. For number C, C would be 48 degrees also. These are alternate interior angles. They are on alternate sides of the transversal, and they are inside my parallel lines. And on D, B would also be 48 degrees, and that is because they are alternate exterior angles. They are on opposite sides of the transversal. One's below and one's above, and they are outside the parallel lines. Our new vocabulary word for today is auxiliary line. So we would use an auxiliary line for solving some problems whenever we don't have enough lines drawn and we have to prove a point. So if I have a picture, let's draw some parallel lines here. So I've got a parallel line here, a parallel line there, and then I'll just put in some segments here. And say I've got a segment that goes this way and a segment that comes back here. You would think that there would be not enough information to follow anything through the picture. But if I said that this was 45 degrees right here, I could draw an auxiliary line right through the middle. And once I do that, I've got a lot more places I can fill in. So I can say that this angle down here is 45. And if I have this angle over here is, say, it's like 51 degrees, then I know that this one over here has to be 51 degrees. Those are alternate interior angles, the 51s, and the 45s are alternate interiors. And so now I know this big angle in the middle would be 96 degrees. So let's look at that in the pictures that we're going to use for the problem in the book. So if this is 41, x has to be 41. So if I've got a 41 up here, then I have to have a 41 right here. And on this one, if this is 35, the y is 35. So in my picture, if this is 35 up here, this has to be 35 down here. And so this angle W, so the measure of angle W has to be the 41 plus the 35 degrees, which makes the measure of angle W equal to 76 degrees. So that's how we're going to use this auxiliary line, by drawing a dotted line that's not originally in the picture. So now we need to start working our way through the exercises. So in this problem, we need to figure out how to get 53 through to C, A, and B. So working our way through the diagram here. 53 would be an alternate exterior angle to B, so this would also be 53 degrees over here. So on A, the reason for that one would be alternate exterior angles. A and B. A and B would be vertical angles, so B would be a vertical angle. Okay, so A and B are vertical angles, 53 and B are alternate exterior angles, and then A and C, so this is also 53 here, let me fill that in. So if I take 180 and I subtract the 53, so that's 127, C is going to be 127, and I got that because A and C are on the same side. And they are interiors. The same side interiors are supplementary. Okay, so same side interiors are supplementary. That gives me the 180 minus 53 to get to the C. Question number 2. If I extend my lines a little bit, so if I extend this one over and I extend this one over, let's just match those up real nice here, and then I extend this one down, you can see your parallel lines with your transversal. And so you know if this is 35 here, you could do alternate interiors to get 35 degrees right here. So I did alternate interior angles first to get my 35 up there, and then the 35 and the D would be a linear pair. Alright, so I did a linear pair, which would mean take the 180 minus the 35. And if 180 minus 35, write it that way, 0 minus 5 is 5. Borrow 1 from the 8, make it into 7. 7 minus 3 is 4. And I get that D has to be 145 degrees, using alternate interior angles and a linear pair. 3 gets a little bit more complex. Let me add some of these lines in there again. So let me add my parallel lines. Here's my parallel line, and here's a parallel line. And let me put in one of the transversals. So let me put in this one. So if I look at the two green parallel lines and the fuchsia transversal, this 54 would be an alternate interior angle. Alternate interior angle. And so angle E, the measure of angle E, would be equal to 54 degrees. Okay, alternate interior angle. So that gets me a 54 over 2 here. Okay, then if I look at the other set, so let's move this down. To find F, you're going to have to do a little bit more work. So there's a couple different ways. You could go 112 vertical across, and then you have the same side interiors. You could do a linear pair, and then you have alternate interiors. You could do a linear pair, and then you have correspondings. So there's lots of different ways to go about this next one. They're all the same amount of steps. They're all the same amount of math. So it doesn't matter which way you go. So I think I'm going to go across here with a linear pair, and then I'm going to go down there with a corresponding. So let me change that to a different color here. There we go. Oops. Let's just delete that off and try that again. So if I go across here, that's going to be linear pair. And then I'm going to go from here down to there, which is going to be a corresponding. Okay, so linear pair. Linear pair means that I am going to take 180 minus the 112, and that's going to be an 8. Borrow 1 from the 8, make it a 7. 7 minus 1 is 6. So this makes this degrees right here 68 degrees. And then if it's corresponding, corresponding is congruent or the same angle, so F has to be 68 degrees since it's corresponding to this one up here. Right? So that's equal to F. And I've got my reasons for justifying. On the 54, that's alternate interior angles, and for the 112, we went linear pair to get to 68, and then corresponding to get the 68 down there. Okay, next picture. So here we're going to need to add in some extra lines. So here is, why is it doing that? Let's grab a line tool. There we go. Okay, so I need to add that line into this picture. Once I have that line in the picture, I can then see where my alternate interiors and alternate exteriors and all that are. I can extend these lines out if that helps you. So I've drawn my red auxiliary line right through the vertex of this angle where G is. So now I know that this 56 right here would be an alternate interior to this angle over here, right? These two are alternate interiors. So this is also 56 degrees. Okay, so I have alternate interiors, angles, and that gets me my 56 degrees coming across to this center part right here. And then this 144, I have to somehow get this rest of this G here. So I can either say that these are the same side interiors. I could go linear pair and then go to alternate interiors. Those would be the two ways. The easiest way is go straight with same side interior. So I've got same side. So that same side of my transversal and interior. Interior means between my parallel line. So between this black parallel line with this red auxiliary parallel line. So this 144, and these have to be supplementary. So same side interiors are supplementary. So I take the 180, I subtract off the 144, and that's going to give you a 6. Borrow 1 from the 8, make it a 7. 7, that's going to give you 3. So that makes this angle here 36 degrees. Okay, then we got to find G, and G would be using my angle addition postulate. Angle addition postulate. And my angle addition postulate says that I can just add the 56 plus the 36, and that gets me my whole angle G. And so that is going to be 92 degrees for G. Okay, so alternate interior angles for getting the 56 here. Same side interior angles are supplementary to get that 36, and angle addition postulate to just add these two together to get G. Okay, the last one from the examples, from the exercises. So I think I've already added an auxiliary line to my picture here. Yep, there's my auxiliary line. Put it right there. Let's make it dotted so you can see it as an auxiliary line. I might need to extend some of my lines. So if I extend this line here so I can see it better, and I can extend this line down here so I can see it better. All right, so this 98 and this part of the H, so this angle and this angle, these two would be on the same side and between these two parallel lines. So that is a same side interior. Same side interior. And we know that those are supplementary, so they add to 180. So same side interiors are supplementary. So I take 180 and I subtract the 98 off of that, and I get 82 degrees. So this angle over here has to be 82 degrees. Then I know that this angle here is 160, and I'm looking for the rest of that one. Again, these are parallel lines, and I am inside and on the same side. So I have another set of same side interiors, and they are supplementary. So same side interior angles are supplementary. So if I take 180 and I subtract off 162, you get 18 degrees. So this little one over here is 18 degrees. And then I can do my angle addition postulate. Angle addition postulate. And that says I can add the 18 and the 82 and give the whole angle H. So I know the measure of angle H is going to be equal to the 18 plus the 82. And when I do that, I get 100 degrees. So the measure of angle H is 100 degrees. Okay, so you need to do your homework, and I will finish up 6 through 10 examples in the next video.